And I'm going to go ahead and introduce our next speaker, who is Jonas Muff, who is already connected. I can see your video. You're still muted, but I'm going to introduce you already. Jonas, thank you so much for finding the time. Jonas is a CEO of Vara, which is a Berlin company who have a fantastic project, in my opinion, breast cancer screening product powered by AI. And a little bit of a side story how this all came up, how come that we have a professional who is not a privacy expert or not full-time job privacy expert at least, speaking at a privacy conference some years ago. I don't remember when exactly it was, but feels like a few years ago when I just met Jonas and we were at a dinner. We were speaking about what we are doing, and Jonas told me about what Vara is doing, and it sounded fascinating. And it sounded like a lot of personal data too. I mean, imagine a breast cancer screening software powered by artificial intelligence on top of that. And they told me a story, Jonas told me a story about, yes, we are aware about privacy and we are aware about GDPR. We are also in Berlin, in the heart of, European startup scene, and obviously subject to GDPR. And they told me about how they went to their server provider because those of you who are not new to GDPR, you know that you need to check your vendors and see your vendors, including your server provider, including whoever is seen as the most natural thing to have as the prolongation of your own privacy program. And so Jonas told me sort of how they actually went to physical location of a server to check how exactly they're treating the data. And that I found fascinating because most of the companies do that check of a vendor only on the level of documentation. And I thought it's going to be really interesting to hear Vara's experience about where AI meets privacy and what struggles they have, what advantages, what success stories they have. And before I give you the floor, Jonas, do you prefer to have questions asked at the end of the presentation, or should I give them to you as they appear? What is easier for you?
Well, first of all, thank you very much for having me. It's a great pleasure to be here, and also thank you for the great introduction. And yes, indeed, it was a fun dinner and a fun story about the physical inspection of the server center. And now back to your question. However you would prefer it, I would say. So as you will see in a second, my presentation is divided into a couple of subparts, and so it would be natural to kind of stop after each part of the presentation and see if you have urgent questions that came up. So we can do it that way, or we can also wait until the end. But I think in order for it to be as interactive as possible, you can just go ahead and interrupt me whenever you feel like, or wait until the section comes to an end.
Okay, fantastic. Then I'm going to switch off my video and audio right now. And if you see me switching on the video, you know that there is a question or a comment. Okay?
Sounds good.
Fantastic. The floor is yours.
Cool. Thank you. And first of all, I hope that you can all see both my camera and hopefully also the screen that I shared. Great.
Yes,
cool.
It works.
That's a good start then. So yeah, again, thank you for the invitation to this conference, to this GDPR day. And as always, when I get invited to a conversation, conference or giving a talk somewhere, I'm asking myself, what's the purpose of me being there, and what value can I add? And I think in this case, it's pretty clear, as you said already before, Maria. I'm probably one of the only, let's say, not full-time data privacy experts, GDPR enthusiasts at the table. And so I think what I can bring to the table really is a perspective from the entrepreneurial, the business side of things, a very concrete use case of where data privacy is lived as a competitive advantage in the startup scene. And so I hope I can provide a lot of practical experience and hope also for a very interactive discussion. So as I quickly said before, I've structured the talk into five pieces, five subparts of the presentation. First, I'm going to explain what we're doing. So basically, what breast cancer screening, our market, really is all about, and how VARA can help there. I think it's important to just provide a certain context, such that we can then dive into what role data plays. Data is obviously very important for us, but what exactly is it that is so elementary about data in our case? Then also what challenges that obviously introduces from a data privacy perspective, what best practices we have established at VARA, and also very honestly and transparently what open challenges we still haven't resolved, or what challenges are only partially resolved. So that's going to be the agenda. And as I said before, Maria, just like interrupt me whenever you feel like, and we can take it from there and see what direction you'd like to take it. So I'll get started with the first part. What is breast cancer screening, and how can VARA help? And I think for that, maybe very briefly about me and my company. So I'm the CEO and founder of VARA, a Berlin-based startup in the field of machine learning, deep learning. And basically our mission is very ambitious. Obviously, it's basically to give every woman in the world a chance for an early enough diagnosis, in the breast cancer space. And I'm going to explain what that means. So to start with, obviously, nothing very new to most of you, I would assume. Breast cancer is pretty evil. 1 out of 8 women develop breast cancer, so it's pretty prevalent as well. 1.5 billion women are at risk at this point globally, and unfortunately still the most deadly cancer amongst women globally as well. And so a pretty big problem. And the good news about it, however, is that when you find breast cancer super early, or as early as possible, then it's usually curable. That is highlighted by this graph here. As you can see, if breast cancer is detected only in stage 4, which is here highlighted in lila and purple, then unfortunately the survival rate is quite low. However, if breast cancer is detected in the earliest stage, in stage 1, then the survival rate is almost 100%. So the message of that really is that breast cancer is not something people or women need to die from, but rather something that is curable if detected very early on. And so luckily in at least the developed worlds, the developed markets, breast cancer screening has evolved. So basically a systematic search for early signs of breast cancer in mammograms, so basically X-ray images. As you can see here on this graph, women are being invited usually every 2nd year, and then there's an image being taken, an X-ray, and then radiologists are basically looking at these X-rays, trying to spot very, very early signs of breast cancer that can present themselves as, for example, calcifications or masses. And as you can see already, they're extremely hard to find. They're often very, very subtle, very small findings, and so a pretty tedious and complex task for these specialized radiologists to actually go for. And as I already said, that is a very tedious, and also I think maybe even more important, a very repetitive task. So radiologists are sitting basically in front of their workstation the whole day, and then they need to find these early signs, and most of the cases are totally normal. So it's a very satisfactory search, where obviously radiologists are getting tired pretty quickly. And that is mainly because of that graph here. I'll try to explain it a bit. Basically, breast cancer screening is all about finding early signs of cancer in women without any symptoms, which means, in other words, that fortunately on the surface of it, most women don't have anything, so they're totally normal. And so on these mammograms that I showed before, usually radiologists wouldn't find anything because simply there is nothing to see. And that sounds great on the first glance. However, it's actually pretty tough for radiologists because they need to find the needle in the haystack. They need to find the 3 out of 100 women that potentially have something, and the 0.7% of all women that actually have cancer. So it's super hard to find the cancer, because cancer is not that prevalent. And so just to provide you some further detail before I'm going to move on more to the data side of the business. But unfortunately, and that's obviously quite sad, because it's such a repetitive and tiring task, radiologists unfortunately miss quite a lot. So 25% in Germany, which is noteworthy, one of the best screening programs in the world. Even in Germany, radiologists miss 25%, which means that every fourth cancer that already would be visible actually isn't detected, which is obviously pretty shocking on first glance, but not that surprising. If we take a look at why these errors occur, it's usually because humans are humans, and humans get tired. Repetitive work is not something that we like as humans. There are cognitive biases at play. Small findings are hard to see, so the human eye can be overwhelmed quite quickly. And what you can see here on that image, I always try to put it into my presentation simply because it's, I think, quite eye-opening. That's a study that was conducted at Harvard Medical School, so arguably one of the best schools in the world. And 73% of all radiologists didn't spot that monkey, that gorilla, that is very visible on that, in that case, lung CT. And I think that just underlines how cognitive biases are basically at play, and that we need to do something about it. And that introduces deep learning. I'm not sure how deep I need to get at this point, but basically we're now in the domain of artificial intelligence, and we're now in a subdomain of it called deep learning, which is a specific technique of machine learning that uses neural networks, just to learn very complicated, complex patterns in complex data structures such as images. And without going too much into the technical side of things, just a small illustration that shows how deep learning, roughly works. Basically, you're feeding an algorithm and a model with a lot of input data. In this case, the images of the cats, and then you train a model to basically fulfill a task such as classifying what images can be seen. And that's a quite interesting technology that has greatly advanced recently, especially in image recognition, which is obviously what we try to do at VARA. So just briefly, how that looks like. We train VARA to find patterns on these mammograms that I explained before. And as you can see over time, after so-called training iterations, basically, the algorithm gets more and more confident, and while in the beginning, oftentimes far away from actually something suspicious, it gets much more confident over time. And in the end, after like 12,000 training iterations, it actually quite confidently is able to find cancers, at least in this easy example, which is obviously extremely powerful. And that's basically in a nutshell what we're trying to do at VARA. And so VARA is basically fulfilling two tasks. One is that we try to automate the normals. So we try to help radiologists by basically relieving radiologists from very repetitive workloads. And I think more importantly for today, the safety net, our second product, as this small video here shows, basically is warning radiologists when they have something or have missed something that the algorithm thinks is most likely a cancer. And so a safety net, quite literally, basically as a last warning signal, basically before radiologists potentially would miss a cancer. And so I think, pretty interesting example of applying deep learning. Obviously, we're very proud of that. And I just wanted to share that with you before we get into the fundamentals from a data privacy perspective. There was a lot of content in a pretty, hopefully pretty intuitive way, but still, I want to check in with you, Masha, if there are questions that you'd like to ask on behalf of the audience before I move on explaining what role data plays for us.
There are yet no questions, but there is definitely a comment from my side that I find it very useful that you're given an introduction into not only the product, but the problematic or the context that you're trying to solve. Because to us, to privacy experts, it usually You know, we see AI, we hear AI, we hear problem very often. And I mean, by AI, we most often we mean machine learning aspect of it. So thank you very much for giving the intro.
Cool. Yeah, that actually was exactly the purpose. I think also the next part is not going to be about data privacy per se, but more about basically the role of data. And I think also based on my experience talking to data privacy officers of our customers, which is very easy probably for you to believe. You know, one of the key stakeholders we need to have in the board when we sell to a hospital or to a radiology center. And I always find it extremely useful to explain them why we need data, you know, that we don't need data only for commercial purposes, but basically mainly needed for fulfilling regulatory requirements and for ensuring patient safety, which is, I guess, in the end, what doctors also care about the most.
I really like that approach. It is something that I use, this question of why, it's something that I use with every client, with every product, every service. We always start with the why. There always has to be a very exact answer to the question why you need this or that data. And only after that, we're going to talk about, do we have a legal basis? Do we have technical organization measures, blah, blah, blah. There's always the why we have to start with. Okay, exactly. I'm going to switch off for now.
Cool. Yeah, I like the energy. So the first part was all about what our company is all about and why we develop what we're developing, and therefore also why we need the data in a way. The second part is my favorite part, so I hope you're gonna enjoy it. It's basically you know, depicting what the data pipeline looks like. So what is it all about? That, you know, what data is what does it mean to us, and why do we need it, and why is it so important? And I think, you know, when you think AI, you think problem, right? That makes sense. And I think when you think AI, then, you know, a lot of people also just think about using data to train an algorithm to then sell the algorithm. But actually, there's so much more to it. And I hope I can add some benefit here by explaining what the data journey looks like for a company like ours. So it's all about, in the beginning, data access, the obvious part, I would say. So getting access to data that you can then train your algorithm with. Second, however, it's also about data curation. So basically working with the data to make it useful for an algorithm. Thirdly, very importantly, it's about evaluation. So basically fulfilling regulatory purposes, making sure that the algorithm really solves a problem and really solves it well. And then fourth, and I think one that is mostly overlooked, is monitoring. So basically monitoring what the algorithm is doing while being used by, in our case, radiologists on actual, you know, patients. And to provide some more detail, it's going to be a bit quicker than the first part, but basically what that all means. Data access, the first part is, as I said, the most obvious one. We need, you know, huge data sets, obviously, to train machine learning models. We need not only the image data in our case, so the X-rays, the mammograms, but also the so-called ground truth data, means you know, reports that radiologists have written back then, but also retrospectively the biopsies. So basically the actual tissue examinations about whether a cancer really was a cancer or maybe it was a false positive. And so an algorithm always needs the ground truth data as well in order to be trained. And then thirdly, and also quite counterintuitive, we need also longitudinal data, which means that for the same patient, we need multiple iterations, multiple screenings in our case, because it's important to understand what long-term effects the patients were undergoing and what data has accumulated over time, such that the algorithm learns the full history, if you will, and can recognize also very small patterns on the images later on. So these are the three, let's say, subtypes of data that we need. Once we have the data, we need to curate the data, which means in our case, annotations. You know, algorithms are still very bad learning basically just on the images. We need to feed them with annotations. So basically image-based, almost pixel-wise depictions of where exactly something suspicious on the images has been. And so in our case, we actually developed our own annotation tool. So basically an own R&D product, if you will. We then hired around 15 radiologists that were basically using this annotation tool to to annotate around 50,000 mammograms. So basically 50,000 times we let them mark the findings on the images according to our guidelines. And also we had to develop quality assurance tools to ensure that the annotations actually are of highest quality for the algorithm to learn. And so just to give you some context about that data itself is not even enough. We need to curate the data. We need to continuously work with it to make it as valuable as somehow possible. And then maybe more interesting now from a data privacy standpoint, once we have developed the model, we need to obviously make sure that we understand how it performs. So does it really fulfill the task? Does it really help patients? And I think here it's not only about the average population, but we need to understand for different subgroups, for different, in our case, different scanner vendors, for different pathology types, for different sizes of cancers, we need to understand how well the AI works. And so we need to really rigorously test that. And also we need all of that to obtain the CE certificate, so the medical device certificate, which we need to, from a regulatory standpoint, commercialize our product later on. So as you can see, extremely detailed understanding of how the AI performs, for which we need even more data than for training the algorithm. And then one thing that makes our task even more difficult is that AI doesn't generalize that well. So AI performs differently on some customers and performs differently again on other customers, mainly because of scanner types, mainly because of the demographic differences. And so even for each customer that we go live with, we need retrospective data to ensure patient safety and to ensure that AI doesn't suddenly oversee something that it doesn't on the rest of our data. So for each customer, again, we need data to make sure that the AI fulfills a task in a confident and robust manner. And I think that's actually quite interesting. That's something that most customers and most data privacy officers of our customers don't understand, which makes sense, right? It's like it's not their daily bread and butter, but I think something where I just wanted to sensibilize you for that data is not only here to train and then commercialize a product, but also to really ensure that for each customer we go live with the data suggests that what we're doing is safe for patients, because otherwise we can just stay home, right? If what we're doing is not safe, then there's no reason to do it in the first place. And the last but not least, I think another one that is never anticipated. I've never had a data privacy officer of a customer that basically thought about that from the very beginning, but something that is extremely crucial and from a data privacy standpoint also quite interesting is data monitoring. So basically monitoring whether AI even performs prospectively what the retrospective data before suggested. And so basically, in a way, prospective evidence, understanding, did the model do something that is weird? Do we see a pattern that AI often, let's say, interferes with radiologists, that there's oftentimes a disagreement between AI and human? All of these things are very important for us and obviously also need a legal ground, and therefore it's also kind of fulfilling the picture of our data journey. And so takeaways here are very important to me. Of course, without data, it's impossible to develop AI. Without data, I wouldn't have a job. Without data, my shareholders wouldn't be happy, of course. That's what you already know, I guess. What's new, I hope, is that without data, it's also impossible to obtain regulatory clearance. So we cannot even fulfill regulatory requirements if there's no data. And then thirdly, and I think most new, I guess, is that without data, there's no way that we can ensure that the patients, or in this case, the women, get the best possible safety and therefore the best possible product. So these are the key takeaways for point 2, and the next step that will be going into more like the data privacy lens and view the whole data privacy or the whole data journey from that angle. But again, I see that Maria, you already you're visible again, which means that I hope you have some questions.
I have a question, which you're probably going to cover in the next chapter, but I still want to ask it now because I think it goes neatly with what you were talking about right now. You mentioned, it is very clear to me right now that it is crucially important to have not just have data, but to have a lot of data, probably as much as possible, and not only to create the algorithm, but also to train it and then to keep developing it to ensure that it works the best way. So my question is about data minimization. Do you see ways of, because GDPR has one of the main principles of GDPR is data minimization, and it essentially says that you are only supposed to process the data that you have the purpose for, and the purpose here is very clear, but then at the same time this purpose kind of implies that you need to have as much data as possible, right, which doesn't go together with the data minimization. So do you have any kind of ways of where you could minimize the data and how you go about it in general with ML?
Yeah, that's a very fascinating question, I would say, and indeed one that is constantly kind of accompanying us as we move into the market and with the market. And so yeah, I think one of the examples where I think that potential mismatch of interests might come to the surface is what I talked about before, basically the tests on each of the different customers, right? So before we go live, we run the algorithm on retrospective data for each new customer, each new partner. And that sounds extremely cumbersome. It sounds extremely painful, but it's something we need to do, right? And there, for example, obviously, the more data we get, the more data we have again to then train the algorithm with even more data, right? And I think that's something we don't do because of the data minimization principle, right? Because if we would like to, then it would be easy to convince the customer to give us as much data as possible, and that would actually be good for the customer, even because the product gets better for him. But in a way that's basically going beyond the minimal requirement, which is in this case quality assurance. And so when it comes to quality assurance, there's a lower bound of data we need, and we try to stick to that because of the data minimization principle in a way. And I think that's just one example, but you're right that there's a conflict of interest in a way, and that's one that we need to be very mindful about.
Yeah. That's a very interesting topic to me, and I think that with products that have ML in them, it is something that is a big question to answer and keep answering all the time, because the minimum amount of data is as much as possible. So in that regard, it's interesting to think that direction, but at the same time, I find it really nice that you are starting with the why, that you are starting with why we need that data, because as weird as it might sound, for many companies this is not the case. For many companies, data is being stored and processed and just kept without the use at all and without the purpose, because we are data hoarders, because we keep the data just in case, because exactly what, if you've followed the previous presentation of Alexander Dike, he was talking about deletion concept, and really a lot of companies think about data as an asset, and even if you don't have the purpose for it, you just store it because you probably will need it at some point, which is not the case in AI and in ML specifically. You do need it, you have a purpose for it, right?
Yeah, I think what's interesting also when we now enter to the next stage of the presentation, the different stages here along the data pipeline, they basically come with different purposes, different requirements, and then obviously also different deletion rules on our end, different deletion or data retention periods, for example, differ for data that comes from different sources. But maybe without spoiling too much, let's go into that part if it's okay for you.
Sure.
Basically,
I'm gonna switch off for now.
Yeah. So now, so far that was all like very comfortable environment for me, and now we're getting into the more shaky grounds for me, because as you mentioned before, I'm not working on that every single day. Of course, we have people on my team that are the data privacy experts, but still there are a lot of interesting messages I hope I can convey. And so basically as all of you have now realized in the meantime, that we're operating in this very specific domain, healthcare. And as all of you know, health data is specifically to be protected, obviously, right? That super intuitive and obviously a guiding principle for us, which is why it's the title of the slide. And then basically what this slide suggests is the 4 stages of the data pipeline to the very left, from AI development to evaluation to clinical use and then monitoring. And basically above the line, everything happens retrospectively. So retrospective data of patients that have been with a hospital for the last 10 years, for example. And then everything below is prospective data. So basically patients that are, once the AI is already in play, then visit the hospital and whose data is then processed with the AI, basically. So I hope that makes sense, because it's very important for depicting our data privacy concept. Everything above the line is retrospective data, so data of historic patients, and everything below the line is then prospective data, so current live patients, if you will. And so, as I said before, there are different purposes, so data requirements in a way, along each of these steps. So for AI development, we need retrospective data, for evaluation as well, but here we need customer-specific retrospective data as well to ensure the quality for each customer, to make sure that the algorithm generalizes well. Then for the clinical use, obviously we need the cloud-based, in our case, cloud-based processing of the personal data then in the clinical use, so live. And then last but not least, we need access to the data for multiple months. And here again, this data minimization principle from before, we need data for multiple months, ideally even years, to monitor the AI quality over time. And so, as you can see, different requirements and therefore different challenges. To the very right of the slide, you can see what the key challenges have been for us, or still are sometimes. So obviously for retrospective data, question is, what's the legal ground for sharing the data? We obviously try to anonymize the data. So the question is, what's anonymization, what's pseudonymization, and where's the difference? Then also informational rights that the data subjects have. How can we fulfill them, given that the patients are often haven't been in the hospital since 10 years. So it's quite difficult from an operational standpoint. Then for evaluation, obviously, is quality assurance actually enough of a legal ground for data sharing, yes or no? And then basically all other questions that we depicted already before. And then for prospective use, quite interesting, it's a totally different concept, right? Here we can ask patients for consent quite easily, which is what we're doing. But here the question is really, how's the data processing agreement going to look like? Can personal data really be used based on a processing agreement in the cloud? So can it be shared with us as a data processor? How long can the data be preserved? When does it need to be deleted? Can we use the data for development purposes once it has been used for clinical purposes? So a lot of very interesting and tricky questions. And basically what I'm going to highlight now is how we're doing. So what challenges have we resolved? What challenges haven't we resolved yet? And quite frankly, there are still some open challenges we haven't resolved yet. So also happy for any idea or input that might come across from the audience. Also feel free to shoot me an email. So basically in this color code to the very right of the slide, you can see that we're doing quite fine when it comes to using our product in clinical use, clinical routine. I'm going to explain why. Also, there's no red field, so generally we're fine. We can do what we have to do, but there are a lot of yellow-orange fields, so still a couple of unresolved questions that need our attention for the next couple of months and years to come. And basically, I think I'd like to highlight a couple of best practices. One is basically what's core of our concept along the whole funnel. We basically only work with anonymized data. And obviously, as I said before, the question is really what is real anonymization, what's factual anonymization, and what's potentially only pseudonymization. And that's a question we still, there's still discussion about. But generally, I think we only use data that is provided by our partners if the data is anonymized. And we also have learned that if we leave that part up to the customer, so if we let them anonymize the data, then how can we be sure we only use data that is really anonymized. And so what we have done, we have developed our own software. It's basically a piece of software code that is basically anonymizing the data for the customers. Or in case the data is already anonymized, then we use the software to verify if the data really has been anonymized. So it's basically our own anonymization software, if you will, that we use to anonymize data even in very unstructured data, as you can see in this example. So we're using that code to retrieve anonymized data, and basically, especially when it comes to retrospective data, so everything above the line, we're only using ever anonymized data. There's nothing else that we use, and obviously in the end it's the customer's responsibility to have a legal ground for that anonymization, but that's also something we support our customers with. That's one best practice that I wanted to share. Also, we're thinking about potentially open sourcing that code and making it more accessible, because I think it's quite an important asset in the healthcare domain. And then the second one might not surprise you. I guess it doesn't surprise you. But basically, the two other super important parts of our concept are A, the patient consent, and B, the data processing agreements between the hospital and us. And so that's all regarding the prospective data, where we are on green, as you can see, because as soon as the patient consents to VARA using data for the purpose of improving the diagnosis, then basically we're fine doing quite a lot. And then on top of that, obviously there's a data processing agreement between us and the customer, and then what Maria said before, between us and the cloud provider as well, including doctor secrecy, clauses and all of that, and including us, as she said before, inspecting the service centers. And also maybe one important note here, we had to change the cloud provider twice. So twice we had to change, and we're now with Telekom, a company based in Germany. The data never leaves Germany, and we have quite strong contracts with them after a lot of iterations. So it's a topic that needs to be observed very, very closely, but one that we're doing quite fine about. Yeah, so these are kind of two key best practices that I wanted to share. And then there are 3 slides left to go into the open challenges, but again, wanted to just make sure, to see if you have any questions here at this point, or any additions.
Yeah, I have many questions as always, but one of them about the anonymization software that you have created. Just curious how it works. Do you give that software to the customer, and so the customer runs the data through the software and then gives the data to you, or do you get the data from the customer and then you run it through the anonymization software to then apply to the algorithm?
No, it's the former, of course. So it's important that data never leaves the hospital to us, at least not to us.
That's exactly why the question, yeah.
Yeah, exactly. So we details I'll spare you, but basically we install that software piece on the premises of the customers through remote access, and then they use it.
Wow, that's cool. That sounds like a very creative solution.
Yeah, it works quite well.
Okay. Yeah. All right, go ahead to the challenges. I'm curious.
All right.
To hear about that.
Cool. Yeah, the challenges. Yeah, I'm also curious about them. Not just kidding. Like there are still some. So basically, again, our big picture. And now going into, I highlighted 3. There are more, but I highlighted 3 challenges I think that are crucial for us at this point. Still challenges that are causing some headache for us and also our customers. And so I think the first one is also the key one, I would say, the main challenge, and also the one that is super interesting from my point of view, which is all about patient consent and information obligations for retrospective data. And so again, as a reminder, here we're talking about data that can go 10 years back, so women that have been in the hospitals 10 years ago, and now we want to use their data for quality assurance and algorithm development, and we simply cannot ask them for consent, right? Like, at least we don't know a feasible way of doing that. That's quite hard, especially if we talk about 200,000 patients over the last 10 years for like a big hospital. It's not feasible. And so the question is, how else can you, what other legal grounds do we have for using that data, or at least for anonymizing the data first, right? Which is itself a data processing activity. And so that's still an ambiguous one. In the end, it's the responsibility of the customers. So basically, we couldn't care about it if we would like to, but obviously the customers need support there. And I think there are a couple of things that we can use, but all of them are still ambiguous. Like one is, research purposes. Can we use the data for research purposes? But then again, we develop a software for commercial purposes. So, where does research end and where does it start? So still an open question. Another one would be quality assurance, also a pretty vital interest in a way. But quality assurance only works for once the product is already developed, right? Because otherwise there's no product to be assured. And so again, one that is now for us totally fine, but a couple of years back, simply wasn't applicable. Also, there are a lot of there's a lot of room for interpretation, as you know, and so in consequence, it means that there is a way, but it is not as clear as it should be. Especially for given the second main challenge, which is that if you ask data privacy authorities, which is what we're doing often, then only in Germany you have 17 different data privacy authorities, and no joke, we asked 3 different ones back then, like 3 years back, and from 3 different authorities we got 3 different answers. And so that's just explaining how much harmonization still needs to happen, and how important it also is to have these use cases to discuss about, right? So that's the main challenge that we're facing from a, let's say, strategic standpoint. And then last but not least, and sorry, these taglines are in German, but basically, I think what adds, and it might be super intuitive, customers are scared. They don't know about data privacy. They read in the newspapers every day what Facebook and the likes are doing, and they simply are scared. And I think for good reason too, right? Because there are not that many positive examples. And so given that some of the concept is still ambiguous, the data privacy authorities don't have a harmonized answer to the questions, then the third one is basically the one that is maybe the tip of the iceberg, which is that customers themselves simply haven't been trained, don't know much about, are scared. AI is new, data privacy is new, so basically very hard for them to navigate in this field, and therefore hard for us as well. But as I hope I could provide with that perspective today, we're trying quite hard to navigate that field. We're trying to really use data privacy not as something that's holding us back, but something that is a competitive advantage for us. We'd like to pioneer the way data privacy is applied by a startup in the healthcare space. It's a hard challenge, but we believe one that is going to be fruitful for us further down the lines, and therefore very much a pleasure to be here, and happy to stay connected with all of the attendees, and happy to also answer questions via email.
Great, Jonas, thank you so much. I'm so glad that you found the time. I know that your schedule is crazy. I only have one question that might sound a bit tricky, or might be even a bit personal. I hope you don't mind. Sure. Because I totally agree with all of the challenges that or not all of them, some of them at least, that I can relate to, that there is no harmonized approach among the data protection authorities, and it is a problem for not just for the companies, but for us whose job it is to ensure the compliance for the data privacy professionals. It is a big problem, and we are really looking forward for a bit more of a harmonization between the supervisory authorities. But more generally speaking, you as a representative of business and not representative of GDPR fan club that we are here, more or less, do you see legislations like GDPR, and GDPR specifically, the regulation, as something that, well, how do you put it, as a showstopper kind of thing? Is it something that you find, something that you like annoying, and something that doesn't really work, or something that really is a big disadvantage for business if you have to comply with it? What is your general feeling of the GDPR? I'm just curious, because it's so rare that we have a business representative at the conference.
Great. So thank you for the question. I think generally, and I hope that you believe me, but I like GDPR. Like, it's not something that I view as a fundamental company risk or as a fundamental showstopper or anything like that. I think GDPR itself is an advantage for Europe, politically speaking, and I think theoretically, GDPR gives us the tools that we need. There is anonymization, there is data deletion, there is data processing agreements. So there are a lot of tools that we can play with to make our concept work, and thereby to ensure patient safety. But then I think what's more annoying, and that's also a bit of the hidden agenda that I brought to this talk today and to this conference, if you will. And I hope that you forgive me the personal side of things. But what is more of a difficulty is that I think not all data privacy officers are participating conferences like that. And what I mean by that is basically that we oftentimes find data privacy officers in the market that just out of principle, because they don't know AI, because they don't know, especially the data privacy side of AI, because of uncertainty, they basically completely block us. And I think that's sad, because in the end, because of that, patients don't get the best possible and early as possible diagnosis of breast cancer. And in a way, AI is the only solution to that problem. And so we need to find ways how we can use GDPR to make something great work. And oftentimes I don't see that attitude in the market. I think that's what's rather a showstopper or a potential showstopper. But GDPR itself, I think, is a good basis, and one that we like working with and one that we embrace.
Cool, thank you. I just want to put on the record that we did not pay Jonas to say that. We also didn't provide the text for him. This is something that he said.
It's all free bill. All free bill.
Thank you very much. We are unfortunately already stealing 2 minutes of the next speaker's time, but no worries. I mean, it's not your fault in the end. It's only my fault. Thank you very, very much for your time.